So it's a word problem with a rectangle, so probably the best thing to start with is drawing a picture of a rectangle. We know that the length is 3 meters greater than twice its width. So at this point, we don't know what its length or width is. If I make my width x, and that tells me that the length is 3 greater than twice the width, does that make sense that that length is 2 times the width plus 3, or 3 greater than twice the width? Now the area of this rectangle is less than 55. Now area is length times width. So length times width would equal the area. So we know that our length times our width has to be less than 55. We've just made a quadratic inequality. What are some possible dimensions for this? Well, if we were going to solve this and we distribute that x and subtract the 55 from both sides to make it less than 0, we get 2x squared plus 3x minus 55. This equation does not factor. Not nicely. So then, since it doesn't factor, we have to go to some of our other solutions. We could use completing the square, although I would not recommend this one for completing the squares because you're going to go into fractions. So this is where, if you were solving this by hand, I would use my quadratic formula, or we can use our graphing calculator to solve it. Solving with the quadratic formula, so we'll split it here. Say we could solve this with a quadratic formula, which says that x is equal to negative b plus or minus the square root of b squared, which would be 3 squared, minus 4ac divided by 2a. And if we simplify this, we get negative 3 plus or minus 910, 440, 449 over 4. And if we check what those are on our calculator, so if we do negative 3 plus the square root of 449 divided by 4, we get one possible answer is x equals 4.55, rounded to 2 decimal places. And if we did negative 3 minus the square root of 449 divided by 4, we get another answer at negative 6.05. So that's using the quadratic formula. And we would have our number line, and we put negative 6.05 on there, and 4.55 on there. We look back at our original equation, and since we need it less than 0, these would both be open circles. And looking back at our original equation, we have a parabola that opens up. So if we imagine our graph of our parabola looking like this, we want to find out where it was less than 0. So this would be the section that's true, right in between here. And these sections here would be false. So we could say that our solution is between negative 6.05 and 4.55. Or if you wanted to write that in interval notation, it would look like that. The confusing thing about interval notation is this looks like a point. We write points on graph in the same way. And We use the open brackets to mean everything from negative 6.05 until we get to 4.55. Some cultures, instead of using round brackets this way, French immersion does it with the square brackets backwards. So you might have, if you're coming from French immersion, you would have had that, you would have written it that way. So I don't know. This is square bracket backwards. You might not have done interval notation yet. So we could also, since in order to get those values you needed your calculator, you could have also solved this one with your graphing calculator. Since a calculator would have to be allowed for this one, another way that you could do this is you could take out your graphing calculator. So this is a different solution to the same one. You could type in 2x squared plus 3x minus 55. So 2x squared plus 3x minus 55. And hit graph and see what it looks like. So there's a parabola, and we can't really see all of the parabola. We could zoom out, but you can see both x-intercepts. So remember, how do we find x-intercepts with the graphing calculator? We go second, trace. Here, doesn't say x-intercept, it says zeros. We need to go to the left of one and the right of one. We can't even see our cursor right now, but it tells us what our x-coordinate is. So if I keep going, it looks like I need to keep going. Hopefully the computer doesn't crash. Eventually I'm going to see my cursor. Here it comes. There. Can you see that my cursor is now to the left side of it? Now you can use your arrow keys to go left and right, which I did right there. And it drew a line which is left of our x-intercept. You can also type in a value to go quicker. Can you see that negative 3 is obviously to the right of it? So if I type in negative 3, it'll draw a line right at negative 3 for me, which is quicker than using my cursor to go left and right. Now that I've got a left and right, ask me to guess, I just push enter again. And here's the one that's the negative 6.05. It's the same answer that we got when we used the quadratic formula. If we want to find our other x-intercept, so now we know that one of them is negative 6.05. If we want to find the other one, well, we do the same thing. Second, calculate. Number 2, 0. We need to go the left and the right of it. Again, I'm not going to use the cursor to go all the way across. I can see that it's between 4 and 5. So I'm going to use my left one as 4. Draws a line at 4. My right one is 5. Draws a line at 5. My x-intercept, yes, is in between those two. Push enter and it finds 4.55. Which is exactly the same as we found on our other equation. So from there, once you get your x-intercepts from your graphing calculator, the solution would be the same. You would draw this number line, the same thing as you did before. You could see, because you have the graph, that the parabola matches up with what we drew with our dotted line. And then you could find out which section is true and which section is false, and be able to write the solution in the same way. 8 and 13 are ones that you can do for practice.